So this talk is about the VISR Framework, which is the technical underpinning of much of the research done in S3A. So what is it? So first, it's a name, somewhat randomly chosen, versatile interactive scene renderer, but much more important, it's a software framework for audio processing, and as it has been said before, it's the basis of the S3A object-based pipeline. So as a software, it's a component-based architecture, which means that audio algorithms are composed as combinations of connected building blocks, as you can see below. These are hierarchical. That means that building blocks can be composed of building blocks as well, and this makes the construction of complex flows and the reuse of parts very similar. And one particular way of reusing software is that in VISR you can adapt the same components for use in different environments, ranging from standalone real-time renderers to offline simulations to use in audio workstation plugins, which we will see about later, or using the same code in Maximus-P externals. So what's contained in the VISR framework? So on the one hand, we have primitive functionality ranging from standard DSP stuff as gains, matrices, filters, to components specific to to spatial audio, for example, calculators for VBAP, this compensate amplitude panning, higher order ambisonics, and so on. We have support for our S3A object model in the form of encoders, decoders, or specific support for the reverb object, and finally some infrastructure such as networking or signal routing and so on. On the other hand, we have more complete signal flows, which we often call renderer. For example, the whole reproduction end of the S3A pipeline is implemented for loudspeakers in the object-based loudspeaker renderer. This includes a variant for this semantically informed processing where we integrate the metadata adaptation into one renderer. Apart from that, we have a toolbox for binaural synthesis and renderers for array processing, for example, soundbars. So what makes it different? We know there are many softwares for audio processing, also frameworks around, but I think there are some things that make the VISR special. First of all, it's well suited to multi-channel and object-based audio by design. But in my opinion, more important is that we have achieved a seamless integration of C++ and Python code, which means that we can combine rapid prototyping with using mature DSP code, and in this way make it accessible to a larger group of developers and researchers. And finally, but even more important in my opinion, is that we try to create the tool into a typical research workflow, which is shown below, which often starts from algorithm design to some objective evaluation forms of simulations or creating graphs, to interactive testing, especially for adaptive techniques as we are using, to listening tests, and finally a real-time realization. But as you can see and probably know, is that this process involves lots of iterations and loops backward, and using VISR you can do that, but basically using the same code base all the time, and at the same time you achieve a quicker time until you can test something interactively and in real time. So finally, and hopefully most importantly, where can I get it? First of all, we released the VISR as a free and open source package under a permissive license. So this is the S3A software page where you can find all the information, and from installation packages to documentation. It also contains a link to the source code repository, which is hosted on GitHub and includes issue tracking and ways to get involved. And that ends my talk.